Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting up the algebra section for Meet 4. So let's get right into it. So the first thing that shows up a lot, particularly in word problems in Algebra Meet 4, are systems of equations. So a system of equations is set up to solve algebra problems that are involving multiple pieces of information, which means that you're going to set up multiple equations in order to solve for one or maybe two variables. So here's how it works. So we have an example question here that says, the Fishers raise both sheep and chickens on their farm. In total, their farm animals have 73 heads and 270 legs. How many chickens do they have? Now, the difference between this question and other types of questions you may have looked at in algebra previously is that you actually have multiple pieces of information that require you to set up multiple equations to solve it. And it's in a word problem. Whereas when you get equations before, it might be something like 2x plus 3 equals 5 times 3x plus 1 or something like that. And it's just one equation that you solve algebraically by moving x to one side, and you just solve for x in that way. But this is different. So we have to learn actually how to set up systems of equations first before we learn how to solve them. So here's what you would do. You'd look at the question and you'd look at what you're trying to find and what you can assign variables to. So it says, the Fishers raise both sheep and chickens on their farm. In total, their farm animals have 73 heads and 270 legs. How many chickens do they have? So first what I would do is, we're trying to find the amount of chickens that they have. So we need to create a variable to represent how many chickens there are on their farm. We're to call that C. So C is the number of chickens they have on their farm. Number of chickens. Now, you can't really set up any equations just using the variable C, right? Because you know the amount of chickens and sheep they have. Well, you know that those will add up to a certain number. You know that they'll add up to 73 because there's one head for each of those animals. So you also need to create a variable to represent the amount of sheep that are on the farm. And that's the other piece of information that you're not solving for, but you need a variable to represent in order to solve this question. So S is going to represent the number of sheep on the farm. All right, so now let's set up our equations. Because we have variables for everything we need a variable for. We have a variable which is C for the number of chickens and a variable S for the number of sheep. So we're going to set up our first equation based off the pieces of information this question gives us. And the first piece is that in total, their farm animals have 73 heads. All right, so a chicken has one head, a sheep has one head. So if we just add the amount of chickens to the sheep, C plus S, that's going to get us 73. Because for each chicken, there's a head, for each sheep, there's a head. So therefore, if you add the total amount of chickens and the total amount of sheep, then that's going to give you a total of 73 heads. All right, so we set up one equation. The next equation can be set up from this piece of information. They have 270 legs in total. So here's where it gets a little bit more tricky. So a chicken has 2 legs, which means that for every chicken you have, there are going to be 2 total legs. So if you had, say C was 1, say you had 1 chicken, then you would have 2 legs for that chicken. So 2 legs. Oops, 2 legs. If C was 5, say you had 5 chickens, then you would have 10 legs. Oops, shouldn't put an equal sign there. You'd have 10 legs because each chicken has 2 legs total, so 5 times 2 is 10. So this is why in the question, you take 2 and you or in the equation that you're setting up, you take 2 and multiply it by C, because this here, 2C, is going to represent how many legs total your chickens have on that farm based off how many chickens there are. All right, and then next, you want to add that to how many legs the sheep have in total. So the sheep are each going to have 4 legs, which means that if the amount of sheep is 1, then you'd have 4 legs total. And if the amount of sheep were 5, for example, S equals 5, then you'd have 20 legs total, because it's always 4 times the amount of sheep that you have. That's how many legs of sheep you have. So you'd add the 2 times C, which represents how many chicken legs there are, and add it to 4 times S, which represents how many sheep legs there are, because there's 4 legs for every sheep. And then that's going to equal 270. And now that you have your two equations, you can actually solve this system. And that's what we'll get into in the next slide. All right, so now we're going to talk about how to actually solve those systems of equations with a strategy called elimination. So you'll notice here that I actually have a different question than we had on the last slide. And that's because it's really important that we know how to set up these equations and how to set up these systems, because otherwise we're not going to be able to solve them correctly. So that's why it's just more practice in setting up equations first so we can then solve them. So first, it says 3 years ago, Anna was half as old as her sister Caroline is now. If Caroline is 3 years older than Anna now, how old will Anna be in 4 years? All right, so when it comes to solving systems of equations, the first step, here are the steps for solving, the first step is always just to set up the system. So let's do that first. That's something that we've already learned. So the two variables that we have in the equation, the two numbers that will change are Anna's age and Caroline's age, because it's asking us how old will Anna be in 4 years. So we need to find Anna's age, and then at the end we can just add 4 to that. So we're going to call A Anna's age. Anna's age. All right, and then we can create a variable for Caroline's age as well, because Anna's age and Caroline's age, those are kind of based off each other in the question. Caroline's age also represents a numerical value that we need in order to solve this question. So we're going to say C represents Caroline's age. Caroline's age. All right, so now we have our two variables, A, which is Anna's age, and C, which is Caroline's age. So now we can set up our equations. And we can just do that based off, the pieces of information we get in the question. So the first piece of information is actually in the first sentence. It says 3 years ago, Anna was half as old as her sister Caroline is now. So if we take Anna's age and subtract 3, which represents 3 years ago, and then we multiply that by 2, that should equal Caroline's age minus 3, which represents Caroline's age 3 years ago. Because remember, here's why. It says 3 years ago, so that's why we subtract 3 from both Anna's and Caroline's age to represent what their ages were 3 years ago. And then if Anna was half as old as Caroline, then 2 times Anna's age 3 years ago, or 2 times A minus 3, should get us Caroline's age 3 years ago. So that's why we have 2 times A minus 3 equals C minus 3. Alternatively, if you wanted to write it like this, A minus 3 equals 1/2 C minus 3, you could also write it like that, because that represents that half of Caroline's age 3 years ago will equals Anna's age 3 years ago. But either of those are correct, so we're just going to use this first equation, 2 times A minus 3 equals C minus 3. All right, now let's set up our second equation, because we can't just solve with one equation. So there's always going to be at least one more to set up. All right, so it says if Caroline is 3 years older than Anna now, how old will Anna be in 4 years? So we don't actually have to worry about this part, because this is like the question, right? So we can worry about that later. Once we find Anna's age, we can just add 4 to it. But this is really the piece of information. If Caroline is 3 years older than Anna now, all right, so that's actually a lot more of a simple equation to set up, right? Because if Caroline is 3 years older, then Anna's age, which is A, plus 3 should be equal to C, or Anna's age plus 3 is equal to Caroline's age. All right, so now we have our two equations set up, so we can move on to the next step. All right, step number 2 is to eliminate one variable. And there are a few ways to solve systems of equations once you get to this step. But this is just one of the more efficient ways. It's called elimination. And it's when you essentially take your two equations and you subtract them to get one variable completely out of the equations. So here's how you eliminate a variable. All right, so what we need to do is we need to make it so there are the same variables in the same number of each variables, or of at least one variable in both equations. So here's what I mean by that. So the first thing we want to do is always simplify whatever equations we have. So like this is just basic algebra. If you see a parentheses like this, 2 times a minus 3, we always want to simplify that because that just makes the equation a little bit more simple and a lot easier to do addition and subtraction on. So let's distribute this 2 to multiply by a and to multiply by minus 3. So we get 2a, and then 2 times negative 3 is negative 6. So 2a minus 6 equals c minus 3. All right, and now what you want to do is you kind of want to isolate one variable, right? So let's kind of isolate one variable. So we're going to say, we're going to isolate, actually no, this is okay. So what we want to do though is it's not necessarily isolating one variable, but making it so we have the same amount of some variable in both equations. And we actually do. So you'll notice that in both equations, we have one c. In this equation, we have one positive c. And in this equation, we also have one positive c. And why is that important? It's because we can subtract the equations and completely get rid of that c, right? So here's how that works. And this is where it gets a little bit complicated. So I write my first equation, 2a minus 6 equals c minus 3. And I set this up like a normal subtraction problem, right? So now I'm subtracting this equation from it. So it's as if you're subtracting any number. You write this equation under this one, right? And you want to write it so like terms, which means the same variables or constants, align under each other. So I want the a's to be under each other. I want like 6 and 3 being on top and under each other is like fine because those are both just regular numbers. And then that's going to equal c. And we'll just say c plus 0 for now. So we have something under this 3 as well. All right, and now we subtract this equation. So this is how the subtraction works. So you have 2a here, and you want to subtract a from it, right? Because that's what this means. You have the a under 2a, so you say 2a minus a is, and then 2a minus a would be a. All right, then you move on to your next one. Here you have a negative 6, and you're subtracting a positive 3. So you do negative 6 minus 3, which is negative 9. So a minus 9. And then that's going to be equal to, and this is where the elimination comes in. You have c minus c. And this is why they had to be the same number of each type of variable in both equations. Because when you do c minus c, you get 0. And now you've eliminated c from the equation, and you can just solve for a after you finish subtracting. And then finally, you can't forget about this negative 3. Negative 3 minus 0, or since there's nothing under there, you can just move it down. It's just negative 3. So 0 minus 3. So now you have an equation with just a in it. So you have a minus 9 equals, and then this 0 doesn't really matter because it's 0. So a minus 9 equals negative 3. And now if you want to solve for a, then you get a equals 6. Because if you add 9 to both sides of the equation to cancel out this minus 9, so and add 9 here, that gets you a, and then negative 3 plus 9 equals 6. So we know that Anna's age will be 6 years old. And then it says, how old will Anna be in 4 years? So we take 6, which is her age now, and add 4, and that gets us to 10. All right, and I actually forgot to show the last step, but the last step is just to solve algebraically. Like we did here when we had a minus 9 equals negative 3. We just solved for Anna's age algebraically, and we got a equals 6. So just to review how this works, first you set up the system of equations, then you get to the more difficult part, which is elimination. And what you want to do in this is you want to simplify whatever equations you have. So in this equation, we wanted to simplify 2 times a minus 3 because that's distribution, and there's a parentheses, and we want to get rid of all the parentheses. So that's just normal algebraic simplification first. And then you want to make sure that there are the same number of variables, or the same number of one variable in both equations. So like in both equations, we had one c. We had a c here, and we had a c in this equation here. Now, if you had the case where it's like 2a plus 6 equals 2c, right? And you wanted to make sure that there are the same number of c's in both equations, right? So say you wanted 2 c's in both equations as well. You could multiply an entire equation by 2. So here's how that works. So say I wanted to make this equation have two c's in it. So when I subtract, the two c's cancel out, and then I've eliminated c, right? I multiply this entire equation by 2, because what's that going to do? It's going to take this c and turn it into 2c. So if I multiply 2 by 2a minus 6 equals c minus 3, and this doesn't actually change the equation. Like, it changes the numbers in the equation, but the equation will still be equal as long as you multiply everything by 2. Then you can do 2 times 2a is 4a minus, and then 2 times negative 6 is negative 12. 4a minus 12 equals, and then 2 times c is 2c, and then 2 times negative 3 is negative 6. So you have 4a minus 12 equals 2c minus 6. So that's just like a heads up of how you would multiply entire equations to get the same amount of one variable in that equation. So therefore, you can subtract the equations and eliminate that variable completely. All right, so now I have a review question about solving systems of equations using elimination. If you'd like to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. All right, the correct answer to this question was 6 dimes. So let's solve this question. So first it reads, James only has quarters and dimes in his pocket. In total, he has 17 coins, which together are worth $3.35. How many dimes does he have? Now, in any systems of equations problems where we have a word problem like this, our first step is always just to set up that system of equations. And the first step in that is to create the variables we need to create those equations in the first place. So it's asking us how many dimes he has. So naturally, we should create a variable, which I'm going to call d, which will represent how many dimes James has in his pocket. So d is dimes. All right, and then the other variable we need to create, because remember, with systems, usually we need at least 2 equations, or at least 2 variables. The other variable we need to create is one that represents how many quarters he has, because all the pieces of information we get in this question are based off together how many dimes and how many quarters he has. So we need to be able to use that variable in equations as well. So we're going to call that Q, which is how many quarters James has in his pockets. And you can name these variables anything. You could name them X or Y or T, but I choose to call them D and Q because D is the first letter of dimes and Q is the first letter of quarters. So it's just a little bit better for remembering which is which so you don't get them mixed up. All right, so now you have your 2 variables, D and Q. So now we can continue reading the question and look for pieces of information that we can create equations based off of. So first it says, in total, he has 17 coins. So we can stop here because that's a piece of information and create our first equation. Because if D is the amount of dimes he has and Q is the amount of quarters he has, then together, D plus Q, that should be equal to 17. If he has 17 coins in total, then D plus Q will be 17. All right, next piece of information, which together are worth $3.35. Now this one's a little bit harder because somehow we need to create an equation where we add the total amount that the dimes are worth and the total amount that the quarters are worth. Now we know how much dimes and quarters are worth. Dimes are worth 10 cents, so 10 cents, and quarters are worth 25 cents. But we actually can't write them as 10 and 25 in this question because you'll notice that it says are worth $3.35 total, right? So we need to write them in terms of dollars and cents because if it said are worth 335 cents, then we could use 10 cents and 25 cents, but it doesn't. It says $3.35. So we actually need to represent this in terms of dollars, right? So 10 cents is $0.1 and 25 cents is $0.25. So that's how much each the dime and the quarter are worth respectively. So now, in order to figure out how much those dimes are worth that he has in his pocket and how much those quarters are worth that are in his pocket, it's actually just simple math here. We take 0.1, which is how much each dime is worth, and multiply that by the total amount of dimes. So 0.1 times D. And if you don't believe me, I'll do an example here. Say D was 1. If D was 1, then obviously we'd have $0.1 because each dime is worth $0.1. Say D was 7. D equals 7. Well, let's count. So for each time, we have $0.1, so we'll count 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. And then when it got to 7, it got us $0.7. And you'll notice the trend here. You take the amount of dimes and you multiply it by how much each dime is worth, which is $0.1, and that will get you the total cost of the dimes in his pocket. So that's represented by 0.1D. And then similarly, we can do the same thing for the amount of quarters. We take how much each quarter is worth, which is $0.25, and we multiply that by Q. So that will represent how much each of the quarters in his pocket cost. And in total, it says in the question, that will add up to $3.35. $3.35. All right. So now we have our two equations. So that was our first step, setting up our equations, creating our variables. And so now our second step is to solve these equations, or to solve for one variable through elimination, basically eliminating one variable. And remember, when we eliminate variables, we do that by subtracting the equations. And before we subtract the equations, there are two steps that we actually need to do. And the first one is just simplifying all the equations. Remember, so we want to get rid of like all parentheses in the equations, want to make it as simple as possible so it's easy to subtract. So first, this top equation has nothing to simplify. It's a really basic equation. You know, there's nothing to simplify here. But the bottom equation has parentheses in it. And this is just something I do. When I write an equation or put variables in an equation originally, I always put parentheses around them just because I don't want to get anything mixed up or multiply anything by the wrong number or whatever. But now we can get rid of those parentheses now that I've created the original equation. So we can just do 0.1d because it's 0.1 times d. So 0.1d plus 0.25q, because that's what 0.25 times q means. 0.25q equals 335. All right, so great. Now we simplified the equation. So that was the first step when it comes to setting up our elimination subtraction question. So the second step, and the more complicated step, is making it so there are the same amount of one variable in both equations. Now, since it's asking us how many dimes does he have, the most optimal way to solve this question would be that when we eliminate one variable, we want to eliminate q. Because if we get q, the amount of quarters he has, out of the equation, then we'll be left with an equation where we can just solve for d, because d will be the only variable left. And if d is the only variable left and we can solve for d, we can skip an extra step, right? And we can just figure out what d equals to. So if we want to eliminate q, then that means we want to make sure that there are the same amount of q's in each equation. Just to go over why, say we're using this equation to subtract, so d plus q equals 17. If in the other equation I have just one q here, and when I subtract, these q's will cancel out and just become 0, and the only thing I'll have, or the only variable I'll have left is d. So that's why we want to make it so the other equation has just one q in it. And that's when you multiply equations. All right, so I'll write the equation over here. So 0.1d plus 0.25q equals $3.35. All right, so if I want to turn this 0.25q into just 1q, then I can multiply it by 4. But I can't just multiply just that by 4, because that would make the equation not equal anymore. So what I have to do is I have to multiply the entire equation by 4. And this is actually really similar to if you're just using the distributive property. You multiply everything by whatever's outside, and then you keep all the symbols the same. So we'll do that. First you multiply 4 by 0.1d, and that gets you to 0.4d. 0.4d. And then keep the addition symbol here the same, and then add that to 4 times 0.25q, which remember, we set it up so that would equal just 1q. And then that's equal to, because you keep this symbol the same as well, and then 4 times $3.35, which will equal $13 and $13.60, I believe. And I would actually have to check because I just did it in my head. I'm just going to make sure quickly that I didn't make a mistake. Nope, I was incorrect. Oops. So it's not $13.60. It's $13.40. My mistake. All right, so $13.40. All right, so 0.4d plus q equals 1340. So that's perfect. We have our equations set up now in a way that when we subtract, q will be eliminated. So the final step of the elimination part is to actually do it. So let's do that now. So we set up the equations under each other. So the same types of each variables are under each other. So I have the d's under the d's, the q's under the q's, and all the constants, which are just the non-variables, under each other. So that way there's nothing weird going on when we subtract. So now if we subtract these equations, and this is actually a simple part about subtracting equations, you don't have to go from like term to term or add or subtract anything. You can just go from each individual term and subtract those individually. So first we can start with this part, d minus 0.4d. And if you put that in a calculator, that will get you 0.6d. All right, and then we add that to whatever q minus q is. Remember, that was set up, so it subtracts to 0. And now q is eliminated. And then finally, that's equal to 17 minus 1340. And if you put that in your calculator, that will get you $3.60. 360. So 0.6d equals 360. All right. So finally, we have just an algebraic equation that we can solve, right, using our algebra skills. And that's the final step, because this plus 0 doesn't really matter. So our equation is 0.6d equals 360. And so the final step is to get rid of this 0.6, because we want to know what just 1d is equal to, because that's how many dimes he has. So 0.6d over 0.6, because you divide by 0.6 to get rid of it, equals $3.60, or 360 over 0.6. And when you simplify this, you do d equals, and then this simplifies to 6. So you get d equals 6. He has 6 dimes in total in his pocket. All right, now just to quickly review what we've learned this lesson. So we started about talking about systems of equations, which are multiple equations that are set up in algebra problems, usually word problems, in order to represent multiple pieces of information and solve when you have a lot of variables. So we had an example here where we said the Fishers raised both sheep and chickens on their farm. In total, their farm animals have 73 heads and 270 legs. How many chickens do they have? And we set this system of equations up by assigning variables to the sheep and chickens, and then using these pieces of information, 73 heads and 270 legs, to set up 2 separate equations that we could then solve from. And then we actually learned how to solve systems of equations using eliminations with this practice problem. And solving with elimination has 3 steps. So the first is actually setting up the system of equations. The second is eliminating one variable, and that has a few steps to it. First is just simplifying your equations so there's no parentheses or anything in them. Then you want to make sure that there's the same amount of one variable in both of your equations. And then you subtract those equations to eliminate that variable. And then finally, you solve for the other variable algebraically. Then we did a review question where we talked about how many quarters and dimes James has in his pocket. And we said together there were $3.35. He has 17 coins. And he had a total of 6 dimes in his pocket. All right, so that's all I have for today's lesson. I hope it's helpful, and we'll see you next time.